This is Call Me, gathering threat intelligence on telephony scams to detect fraud in South Seas CDF. This will be a full 50-minute briefing session. A couple quick announcements. The business hall is located in Bayside AB. The Kali Linux lab is in Mandalay Bay A. Thanks to everyone for putting your phones on vibrate during the presentation. And let's everyone welcome Ode Marzulli.
Hi everyone. How many of you have received one of these annoying robocalls? Quite a few. I suspect weekly, maybe daily. Turns out robocalls are 21st century nuisance, but we don't know much about them and the whole ecosystem around it. So this is the topic of the call today, of this presentation today. I come from Punjab. We are a startup based out of Atlanta, Georgia, and our main technology is called phone printing, that enables us to identify, locate, and authenticate phone devices just from the call audio, not the headers, just the audio. And so we work with companies to eliminate phone fraud. So today, I will first give you an introduction to our telephony honeypot, which we call Phonypot. Then I will go into how we track spam and scam campaigns, and then what sort of intelligence we gathered on telephony abuse using that telephony honeypot. Finally, I'll provide some conclusive remarks. So, what is Phonypot? Before that, I'm assuming most of you here, since you're a security crowd, know that you cannot trust the caller ID on a phone. Meaning that this very nice lady, whether it is Lisa or Sharon calling you, might actually mean somebody else. And a lot of people fall for it every day around the United States. So the problem is the caller ID. The other problem is that it's pretty much the only information you have on the telephony channel. So this may seem as just something annoying, something that prevents you from, just talking to the people you want to talk to. But there's something much more concerning behind the rise of robocalls, is that after all the data breaches we've seen for the past few years, a lot of your data is already out there, whether it is your name, address, email, maybe your date of birth, maybe your partial social security number. And so not only are scammers trying to maybe get you to pay a small fee for a free cruise or, a small fee to be on the front page of Google, but also they're trying to enhance the profile they have around you. So trying to get more information. Who are you a customer at? Which bank? Which insurance company? How much money do you have? And so on and so forth. And so the picture you see on the right is basically when you answer with robocalls, when you press 1, when you keep talking, when you verify information over a phone, you basically open the door for them to break all the doors of your personal life, any company you have interest with. That's what happens. So it is a serious problem from a security perspective, not just from it's annoying to get these robocalls. So everybody's talking about it, from AT&T to Google, different consumers union, the FCC, the Federal Communication Commission, regularly issues statements about it. But really, besides a few blacklisting apps out there, there's much more to do. And a blacklisting app is a very temporary mitigation strategy. It does not solve the problem. Also, it does not provide much intelligence. And to give you an overview of the numbers, the FTC in 2014 got more than 22 million complaints. You can go online to the FTC website, complain about a particular phone number. You can also complain to the IRS. So Americans lose a lot of money yearly to fraud, and phone fraud is now becoming a big chunk of it. And so more than 1 million Americans, for instance, are reported being targeted by the IRS scam, one of the most famous ones. So what can we do about it? Well, first we want to research telephony fraud in general, because at this point, what we know about phishing, that is, phishing on the voice channel, is very limited. We are pretty much at the state where we were for email spam 20 years ago, and that led to a whole multi-billion-dollar anti-spam industry on on the web. So first we want to understand the whole telephony fraud and scam ecosystem. What's the value chain? How does this work? What are the different groups playing there? Then we would like to gather threat intelligence through measurements and experiments. And finally, of course, design defense strategies and deploy them. So this talk will mostly touch on the first 2 points and then provide insights on the third point. So here it is, our phony pot. Typically, and it varies a little bit, we get about 500,000 calls, and these are unsolicited calls. We don't place calls for our honeypot. These are just, we own old numbers in our honeypot, and we have a system set up so that if anyone calls us, we store the information that phone number A out there called phone number B in our honeypot at time T. So it's very limited information. It's not like an email. And so all these calls are actually placed by a much smaller number of source phone numbers, so about 90,000 per month. And they only call about 40,000 destination phone numbers in our honeypot. So there are several limitations to this data, just saying phone number A called phone number B. First, source phone numbers can be spoofed. So then all you have is a destination in our honeypot was called several times across the day. It's not much. Moreover, most phone numbers only call once or twice. So it's not like you can do machine learning on the historical behavior of any source phone numbers. And you don't have labels. You don't know who's a good guy or who's a bad guy. For instance, for email, you know what a good, legitimate user is doing. For phone numbers, you don't know. And most of the existing research on phone fraud has been on carrier data set, trying to distinguish a legitimate user from illegitimate users. And how you do it is basically you have a very big imbalanced data set. The majority of users are behaving normally, a few bad guys are behaving abnormally. So that actually raises a lot of privacy concerns, because you have to model everyone to be able to model the bad guys. This approach is completely safe from a privacy standpoint. But we needed ground truth. So in the first half of 2016, we recorded 100,000 calls. And a few precision, since in the US there are what is called a two-party consent state, we didn't record everyone. If the call appeared to be coming from a two-party consent state phone number, we did not record. And by recording, I mean that we would pick up the phone automatically and just have a voice say hello and just wait. So a regular user would just say hello, someone there, and eventually hang up. A telemarketer would try to get their spiel out and then just hang up because they realize no one's on the line. But a robocaller will just say everything they need to say and sometimes keep going. We even saw some cases of traffic bumping, just calls where they were rotating recordings until the time we had set for the maximum length of the call was reached and it would hang up. So nobody has ever done any sort of work like that, recording things and trying to get ground truth. The reason we only recorded that among all the calls we get is we didn't want to burn any numbers, and we also wanted to have a sufficient size experiment to see what was going on. So there are several advantages to using a honeypot compared to, for instance, crowdsourced information such as online comments. So we wanted to make sure our honeypot was better. We took a year of data from the top 6 websites about online comments, about phone numbers, and in 2015, that was about 600,000 comments about phone numbers. Our honeypot received 8 million calls that year. And what you see already is that the online comments are very polarized. They only talk across the whole year about 74,000 source numbers, where our honeypot received calls from more than 800,000 phone numbers. And what is more interesting is what is at the bottom, is that 66% of online comments are complaining about only 2% of the source phone numbers in the honeypot. And that's intuitive, because you only go online, complain about a phone number if you have received several calls. So the most heavy callers get complained about. But the remaining 98% of source phone numbers calling us go unnoticed or practically. So this research aimed at not only understanding what the big bad guys are doing, but also what everyone else is doing that's illegitimate. So we want to find out the whole distribution of behavior there is out there. So now I'll go into the system, it's not a product yet, the system we built, and all the details. So first, a little bit of a system overview. Using past calls, we store the call details, so phone number A called phone number B at time t, and the audio recordings. That information goes into a machine learning engine that uses the audio transcription, so the audio is transformed to text, and extract audio features. Based on that, we build a library of known robocallers. And what I mean by known robocallers is actually the audio signature of these known robocallers, and I'll go into that in a minute. So that once you have built that, any new call that we receive, we extract audio features within a few seconds, and then we check our models. Have we already seen these guys? So even if they are calling from a source number that we've never seen, or even if they are spoofing that number, we can still detect them and say, okay, within a few seconds, this is actually known bad guy X or known bad guy Y, and we can stop the call if needed. So this entire talk is based on the audio on the voice channel. Now we go into more details, the transformations of the data. So I will, after that in the following slides, go into each of them, but I want you to understand the process. So you start with N calls, you transcribe the audio, you get N transcripts, that means N text files. Then you do some pre-processing on that, you get bag of words. Then you use some natural language processing, you build a corpus and a dictionary, and now you get a matrix. That's N, the number of calls you had, by W, the number of words you have across all transcripts. So that's a huge matrix. Thousands of rows, several thousand columns. And then we do a procedure called TF-IDF, that's a weighting. And then we do a dimensionality reduction technique called topic modeling. And so we change the size of my matrix, N by W to N by T, where T is much smaller. And once we have that, we check a similarity between the projected transcript. And after that, we do spectral clustering on that, and we find out which calls are actually identical. And once we know which calls are identical, we use the audio features to build models of robocallers. So let me walk you through each step. The call transcription is done with an open source toolkit called Caldi that's designed for speech recognition originally. It's based on deep learning. So you input an audio file. Once you get the text, you remove stop words like V, N, are not useful. You lematize the words. That means you truncate them. You remove words that you only see once, because that means you can't do any analysis on that. And you remove a short transcript. So all the people who said, hello, is someone there? You clean that out. And finally, you get a string of text at the end. So once you get that string of text, you do the natural language processing part. So a few terms here. A corpus, that means all the processed transcripts. And the dictionary are all the words across transcripts. The first thing you do is a transformation called TF-IDF, term frequency inverse document frequency. That's a transformation that changes the weighting. So for instance, if the word press appears twice in a transcript, it's not very important. Most robocallers tell you to press the button. So that word is going to be the weighting is going to be very small because it appears across all transcripts. Whereas a word like Google or medical is not present across all robocalls. So it will have a higher weighting in the transcripts where it appears, and it will comparatively to the word press. Once you have that, you apply something called latent semantic indexing, which is basically a singular value decomposition, and you keep the first singular values. And so on the right is a picture of what a singular value decomposition does. So let's say you take a matrix that represents the picture of a tiger. It's very detailed, it's perfect resolution, everything you need. Now let's say you take only the most important 200 components on the top right. You still see the tiger just fine and most of the details. But if you go to the bottom and you only take the first 10 important components or the first 3 important components, then most of the information is gone. You can barely tell it's a tiger, the details are gone. So we want to be somewhere in the middle, where we have significantly reduced the size of our matrix, and the projection we're doing, but still, have denoise the image, basically, and keep all the relevant information for further processing. So that's what latent semantic indexing does, but we do that on text. So these projections, so the latent semantic indexing will change from the space of words to the space of topics, which is much smaller. We call them projections. These projections have a name. They're called topics. Topics are, in effect, a list of all words in the dictionary, but weighted by importance. And here I'm just putting the first 10 words for each topic. First topic is business listing, online, owner, Google, and Cherry. So it's about one of the well-known Google scams. So imagine this. You have a whole corpus of documents, and one of the most important dimensions of this corpus is basically this Cherry Google listing. It's one of the most prevalent scams. The second one is also about Google, but this time it's about optimizing your listing. The third one is completely different. It's about a home security scam, telling you that you've been referred by a friend or neighbor. The fourth one is a well-known free cruise to the Bahamas survey. And the fifth one is about federal student loans. So already, with just a few topics, you see the major scams automatically emerged. And if you go down in the topics, you start seeing some of the less prevalent ones. So remember, we have these transcripts. And you could do this by keywords, like, for instance, in the online comments. But keywords are extremely noisy. They may cover different types of recordings. And we want to understand each precise campaign. So let's say we take the transcript on top that says, press 1 to save 50% on your electric bill with no money out of pocket, using New Jersey's Sober Company. Transcription is imperfect. This is what you see here. And you take this second transcript. Oh, press 1 to save 50% on your electric bill, blah, 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 using New Jersey's Older Company. So these two, their projections are almost identical. You get 93% cosine similarity. So when you actually go listen to the recordings, they turn out to be the exact same recordings, and they come from two different phone numbers. Now you take the third one that has a few keywords in common, such as New Jersey and electric bills, but it's about something completely different, so it's only 63% similar. And then the last one has the keyword bills in common, but it's not similar at all. So this similarity matrix allows you to automatically detect which recordings are identical and which are just have a few words in common, so that you can really track each separate campaign. So now, imagine you have all these calls, you have all these transcriptions, and you want to know who's similar to one another. So on the left is what I call a similarity matrix. That means each row represents the transcripts, and each column represents another transcript. So the element ij represents the similarity between transcript I and transcript J. And of course, the diagonal is very dark. You're very dark if you're very similar. The diagonal is dark because you're always similar to yourself. But you can't really see much order on the left. You can see that, some transcripts are clearly similar to one another, but you don't really see order. And so we use a technique called spectral clustering. That's a nonlinear way of clustering. It works very well, much better than anything like k-means. And so what it does, it permutes the rows and columns to try and obtain this block diagonal formation. We did some filtering too. And so you find these very nice big blocks that basically say, if you are in this block, it means you all correspond to the exact same recording. And so you see different blocks, and they each correspond to a different campaign. And then you extract each of these clusters and you find out what they are about. And you start seeing that scammers target all kinds of subpopulations. For instance, on the bottom left, it asks you if you need a burial policy. What's one of the scams targeting seniors? Then you have, are you trapped in student loans? And that's more towards young people. You have home security systems, Google business records. A very interesting one, Sherry, who's an online specialist not only for Google, but also for Yahoo and Bing. You also have stuff about the IRS, free cruise to the Bahamas. So each of these small clusters, and you see there are many, gives you the relative importance of each scam out there. And you can extract in these clusters which call that was, at what time that was, and which are the different source phone numbers playing the exact same thing. So now that's when we use our in-house technology called phone printing. We take each cluster, and for all these calls, we extract 150 audio features. For each of them, all the calls that came into our honeypot. And with that, I'll go into what is a phone print. So a phone print is when we receive a call, and we use that not only for the honeypot, but also with all of our clients. We extract 150 factors or features from a machine learning standpoint on every call. And these features cover different aspects of the calls, from the spectrum, so which frequency filters, the codec artifacts, to the noise, with the clarity of the call, the correlation, the signal-to-noise ratio, and finally the loss, the packet loss, robotization, drop frames. And so think about it for a second. Why would this work? If you place a call from the same device, let's say you have two iPhones. Even if they come from the same model, same year, came out of the factory at the same time, there are still artifacts that make them slightly different. And let's say somebody's calling you with a particular phone, whether it's a cell phone or a robodialer from overseas. That means the call will have to go through different types of networks to get to the US. Also means that, for instance, it will go through transatlantic cables. And maybe it was originally a voice over IP call, and in the end it's reaching a landline. So all of this creates artifacts in the audio. So if a call is traveling a lot, you'll have more packet loss. And so that enables us to do two things first, to say, what is the call type? Is it voice over IP? Is it a landline? Is it a cell phone? And also some geolocation. Is it a domestic call or is it an international call? And with that, we can uniquely identify a device. Meaning if you get several calls from the same device, the audio features will be almost exactly the same, even if it's at different times. And that's what everything is based on. So we go, and I would like to highlight that phone prints are completely voice agnostic. So prove it, we have a small experiment. So you take one device, you pick 12 speakers, you combine 10 clips of each speaker, only for a few seconds, and that gets you 120 recordings. Then you only pick 12 samples, one for each speaker, and you put that in the positive class of a phone print. So a phone print is not only the fact that we're extracting features, it's also a kernel classifier, meaning that a kernel classifier is not from a computer science perspective, it's from a machine learning perspective. It is a classifier that is linear in high dimensions, a hyperplane, but when you take it back to a lower dimension, it's actually nonlinear. And so we train a phone print. We put in the positive class the 12 voices, one sample, in the negative class, any other calls from a honeypot. And so that gives you a model. And so if you look on the bottom right, this is the kernel PCA visualizer. That means you go into the kernel space, that high dimensional space, and then you extract the first three main components of that space for information. And in blue, you have all the dots correspond to calls in a honeypot, and that's actually thousands and thousands of calls, but they get collapsed on these dimensions. And in pink, you have these 12 speakers, the different voices from the same device. And what you see is that they are all in the same regions, meaning if the calls come from the same device, even if somebody else is speaking, all their features are well clustered in a particular area. And so you can build a model, you can put a hyperplane there to separate these speakers on this device from anybody else. And that's what we call a phone print. And then to test it, we take the remaining 108 recordings of all the other clips, put them through the same device, and we're like, okay, are these features on the right side of the space, basically? And they are 90% of the time. So what that means is that it doesn't matter who's talking, and phone prints are only about devices. And that's what's important for the next part, when we phone print clusters. So then we put in the classifier, in the positive class, we put all the audio features from all calls in the same cluster. So let's say you take all the, that's are you trapped in your student loans calls, you extract the features. They may come from literally hundreds of source phone numbers. You put that in the positive class. In the negative class, you put all your features from any other call we've seen. And we tested that across more than 50 clusters. And the average performance was 85% true positive rate at 0.25 false positive rate. What that means is if you call back from this particular device, robodialer, cell phone, whatever it is, we know it's you 85.5% of the time, even if you're hiding behind spoof number, even if you're rotating numbers using a spoof phone number, as long as your infrastructure doesn't change. But even if your infrastructure changes, as long as you actually place a few calls to random people in the US, we catch you again after just a few calls. So your infrastructure effectively becomes useless. And we get good performance on spoof number even if you have less than 2 calls per number. So let's say we had 100 calls for the scam and they were using more than 50 source phone numbers, we can still catch them. So good phone print performance on a cluster implies that all calls from this cluster come from the exact same telephony infrastructure. And I mean, at first I was surprised when I got these results. I expected them. I expected that the fact that you have the same recording means it's probably the same guy behind it, because it's not like you're going to sell recording on the black market. Just pick up your phone, make a recording. But I was surprised with how good the performance was. And really, what it means is that there might be less bad guys than these clusters out there, but they have to operate a different robodialer for a particular scam because it's running all day. So this is how we do it. We use the semantics of the calls to have an idea of which calls are actually are coming from the same guy, but we're not sure yet. And it's a way to avoid a combinatorial problem, because a priori, you don't know how many scams are out there, you don't know how many calls they place, and how many sources are behind them. You can't just guess. So this is our first cue. And then, when we go into phone printing, we have ground truth. We know for sure that they are indeed the same infrastructure placing these calls, whether they are overseas or in the US. So now what do we do with it? Well, now that we have identified these clusters, we have fingerprinted the infrastructure behind them, we try and track them and see, what are they up to. So one of the most famous scams is actually the Google scams. But what I mean by Google scams corresponds to more than 10 different recordings. When you go online and you look at comments or crowdsourced information, there seems to be like one Google scam. There are actually several different ones. And they target different Google users from Google Maps, Google Business listings, Google+. And they ask you anything from paying money for front page placement, for unlimited clicks, to verifying personal information. So on the top is the traffic we see in our honeypot from January to June 2016, every day how many calls we get about Google. And you can see that you have nice weekly patterns. Sometimes you have spikes, and not clear why. Because the honeypot is in a sense an observer of the world, it might not be perfectly steady. The traffic may vary depending on who we are targeting. And on the bottom, in orange, you have the number of source phone numbers calling, and in blue, you have the number of destination phone numbers they called in a honeypot. And what you can see is there's a big imbalance. A few source phone numbers are actually calling a lot of destinations. But now let's look at their behavior from a network standpoint. Let's take Sharon, your Google specialist. So on the right, you have a transcript of a typical call. So Sharon, your local Google specialist, says she has front page position available for a business like yours, and you will have unlimited clicks for 24 hours a day at a flat rate. The phone print performance for this particular cluster is with 93% true positive rate. What you see on the left is a red dot is a source phone a phone number that called us about this. A blue dot is a destination phone number in a honeypot. This is the traffic for 6 months, and you have a link in black if there was a call placed. So you see this wide imbalance, this small group, it's a pretty big group, but 253 source phone numbers calling 17,000 destinations, more than 27,000 times. It's just massive robo-dialing. And there's no particular pattern to this one. They're just randomly dialing everyone they can in the US. And remember, a honeypot is an observer of the world. So the traffic is much bigger out there if you take all the United States. Another very similar behavior is actually for Google Business Listing. That tells you need to verify your contact information. And for that particular one, we still got a very good performance, 92% TPR, and a very similar behavior. Just the numbers changed. 410 source phone numbers, and they placed 30,000 calls to 26,000 destinations. So these are the bad, heavy callers that you hear about all the time. But there are some more rampant, less known behavior that we still catch this way. So that's what I said earlier when I mean the distribution of behavior we see. These are debt collectors. So red dot, again, is a source phone number, calling in blue one of our destinations. And this particular debt collector just tells you to call them back. And what you see is that over 6 months, these 7 source phone numbers place 1,300 calls to only 92 destination phone numbers. So the ratio compared to earlier, where it was basically 1, maybe 1 point something calls per destination, is very different. It's 92 to 1,300. This is called targeted harassment tactics, meaning they call the same people over and over. And while a few robocallers for debt collection can be legal, most of them operate in a very shady space, and there have actually been actions made by federal agencies on that topic. And it's election year. We have all heard about the political campaigns. I suspect you may have received calls about the political campaigns. Political robocalls can be legitimate, but not all of them are. So we see a wide variety of robocalls regarding the election. We see support of well-known politicians to different candidates, particularly calling you before a caucus. So on the top, the map of the US is colored by the number of source phone numbers making the calls. So you see that a lot of sources are in New York, Ohio, South Carolina, Nevada, and Florida. And in blue at the bottom are the destination phone numbers receiving the calls. And most of them are in Nevada, Utah, Texas, Florida, and Ohio. I was really surprised by Nevada and Utah, so I went and looked. It's actually because of the caucuses. For the caucuses, we saw a spike in robocalls just before that, telling you to go vote. So you had politicians' wives and significant others asking you to go vote for them. But you also see something that's very, very shady, are donation hotlines, but are not really endorsed. If you actually try and find their name online, they operate very weird websites, and sometimes they trace back to campuses. So when they ask you to donate to your favorite candidate over the phone, please don't do it. Go online to their website if you want to donate money, because it's very dangerous to disclose all your information that way. There are a lot of political surveys, and what's new is that they are fully automated. It goes from, are you likely to vote in this election? Or will you not vote? Press 1 for one, press 2 for the other. Or if you are a Republican or a Democrat, they target you, and then they say, are you likely to vote for this person? Less likely to vote for this person, and you press different buttons. And finally, we also see something that's pretty new. There are live conferences over the phone with politicians. That means if you stay on the line or if you put a button, you will actually be entered in a giant remote conference room where a politician will be giving a speech, and if you press a button, you can ask a question and they will answer them. And they can literally, the companies who do that claim they can reach millions of people at once. So that's a whole new area, and of course you can press a button again and give money. So this all comes down to saying that we've been automating spam detection and tracking, and that goes from the automated detection and phone printing of new clusters, whether they're large or small. So on a regular basis, we receive calls, we record some of them, and if we see a new cluster, we extract the information, phone print them, and store that information. For the known clusters we already see, we automatically update any new source phone number used by a known fraudulent telephony infrastructure. And also, we track the life cycle of these campaigns and their evolution. So on the right, the plot you see is for some of the clusters we have, their relative sizes and the number of source phone numbers calling for these different, placing these different calls. What I'm trying, and it's actually done on a smaller subset of data. What I'm trying to show here is that this is a very generalized problem. We see new scams appearing every other week. We also see scammers change tactics. So some scammers have gone cross-channel, meaning, for instance, with a tech support scam, you will go online, you will get a pop-up at some point while browsing, and it will say, please call this number, you have a virus. You call this number, you end up talking to a tech support scammer who will pretend to fix your computer in exchange for a fee. We have actually called back scammers, trying to understand what they were doing. And that was additional proof that our method was working. Because for different Google scams or other scams, when we call back, you end up in different IVR. So for a particular one, I ended up talking about a business listing, and it was very, very professional. If I hadn't known this was not possible, I would clearly have fallen for it. You ended up talking to someone who had a database with all your information, which business you own, since when, what's your name, what's your date of birth, when was the last time you did something online about it, and so on. And then sometimes we just ended up on a Google Voice number, or we ended up talking to people with very strange accents. So, but for each particular clusters, we ended up talking to a different group. And that was, there are clearly fraudsters, scammers out there with a wide variety of skills. Some of them look so legitimate, anyone can fall for it. Some of them you're like, oh, you have a strange accent, you don't really know what you're talking about, okay, I won't trust you. But it's very widespread. So, how many bad guys are really out there? And, you hear in the news about this robocalling problem, you might think there are thousands and thousands of people doing that. I mean, robodialing is cheap. Voice over IP is cheap. But you do need infrastructure to conduct the scams behind it. And so we had about 1 million calls for several months. Out of this, we recorded about 100,000. Out of that, typically 1/3 are robocalls. We also have a big chunk of telemarketers. And 51% of all of these robocalls come from only 38 distinct telephony infrastructures. And at first, I was like, this is crazy, I hear all the time that this is an unsolvable problem, and we can trace half of the problem to a very small number of telephony infrastructures. And we did more experiments, and we always got the same results. We talked to federal agencies about it. So the bottom line is, this is a manageable problem. This is a problem that can be tackled by law enforcement and federal agencies. This is not something that is insolvable. These call centers might be in the US or abroad, but there are only a few of them that are perpetrating the majority of the problem. And while we do not know yet who they are or where exactly they operate, we have the first data-driven results that show there are only a few of them and we can do something about it with appropriate collaborations. So that's what I would like you to remember today, is that if you exploit the audio channel by extracting audio features, you can actually fingerprint who's behind a portion of calls and uniquely identify who's perpetrating those calls. So, as a conclusion, and this talk is a little over where it was supposed to be because there was a schedule issue. So we recorded over 100,000 calls over several months in 2016. Using machine learning on call patterns, semantics, audio features, we can uniquely identify a telephony infrastructure used by a bad actor hiding behind several source phone numbers, whether these numbers are legitimate or spoofed. And our results show that 51% of these robocalls are placed at only 38 distinct telephony infrastructures, and we can uniquely identify them. Whenever they are used again, we have their fingerprint, we can stop them. So I would like to acknowledge the whole data science team at Pindrop, Hassan, David, Robert, Aaron, Talbot, and Terry, and I will take any questions. Thank you. Go ahead. Do you want to stand next to the mic, maybe, if you don't mind?
How have you seeded the phony tokens in order to collect as much as calls you can? So, because I think it's so challenging to put those numbers somewhere so the scammers can find the numbers and then you can receive the calls.
So we actually put a few calls on SoundCloud, the main scams we see out there, just to educate the public. But this is still research. Like, this work was started less than a year ago, and these are some of our first results. Eventually, we want to bring something to consumers. We just don't have it yet. And we want to make sure that any information we disclose about phone numbers is secure, meaning if your phone number was spoofed by a scammer by accident, I don't want your phone number to end up on some sort of blacklist of known robocallers. That's why we rely so much on the audio fingerprint and not just on phone numbers. But the envisioned defense is that you would have maybe an app that would, within a few seconds of a call when you pick up, analyze everything, checks the library, and tells you this is known bad guy, you should probably hang up, do not provide information on this call. Also, a lot of scammers actually spoof bank phone numbers or insurance company phone numbers and tell you that there's been a weird charge on your credit card and that you should call them back. And you might trust them. So I encourage people to actually go back to their bank records and call the right number. So the problem with phone numbers is that it is so easy to spoof, and so disclosing them, I don't know if it would be very helpful. Does that answer your question?
Somehow. So the other question is that you recorded all the calls, so is it legal? So how did you...
It is legal for one-party consent states. So because we own the destination phone numbers, if you called from an area code that doesn't come from a two-party consent state, we are allowed to record it. Thank you. Another question? Go ahead.
So in the FCC talk, one of the things they're talking about trying to regulate is requiring authentication when you place a phone call. I was wondering what percentage of your data set you found where the callers were spoofed numbers versus just random callers that you could call back and reach.
So I don't have exact figures. It's very hard to tell that the phone number is spoofed unless you're a carrier and you can listen in on the SS7 network. And even that, because it's so huge, it's not easy to do. We definitely know some of these phone numbers are spoofed because they are supposedly attributed to banks, for instance. Or when you try and call them back, even the day of, it's impossible. We also saw behaviors where they know exactly who they've been calling. So if you try to call from a phone number that they didn't robodial, they will not pick up. But if you call back spoofing your own destination phone number, then your call will go through. So it's, yes, I don't have a clear answer for that. I don't have exact numbers.
Thank you.
Sure. We have someone over there, maybe?
Yes, I just want to say I find this topic very fascinating. I actually have two questions for you. The first one is, do you know the amount, does anyone have an estimate of how much money this market makes and how much of these are completely 100% scams versus, like you had said, you talked to someone following up on one of these Google things and it sounded like a very professional company. How much, is there a possibility that this is just a lead for legitimate companies, or is this completely just 100% trying to scam people out of their money? Number one. And then number two is the only way to protect against this or to mitigate this, I would assume, would be to intercept the communication and try to match it with a fingerprint that is fraudulent, and then to just kind of black hole the call. So I don't know mechanically if there's really a way to try to intercept these and not make them be such a nuisance.
Yeah. So first, for your first question, I don't have exact numbers because, for instance, a lot of people don't realize they're scammed until very much after and don't know how to report it. it is such a big problem for big companies like Google or Microsoft with tech support scam to be associated with this very negative press and with people then calling them back and being like, hey, you scammed me. So there are actually a lot of working groups in the industry trying to bring together federal agencies and companies to stop this. I think what is clear is that it is clearly rising, and even though the public may know more about it, recent data from the Better Business Bureau suggests that millennials are very likely to fall for such scams because scammers that know all about you, your phone number, your date of birth, your address, where you went to school, if you have student loans, are they're very good at convincing you they're real, they're legitimate. And the second question, the problem of intercepting calls, it's something that carriers can do. If you're not a carrier, it's pretty complicated. We've actually looked a little bit into it, and we can talk about it a little bit offline if you want.
Great, thank you.
Sure. You had a question over there?
Yeah, just one quick question. I was wondering, you had like 100,000 calls in your sample period there. In terms of destination numbers, what was your sample size? Like how many probe destination phone numbers did you have?
Let me check. We had 44,000 sources, probably about half of that. Typically, the ratio we see is twice as many sources as destination.
Oh, okay. And, on the other topic that he had, there is a service called Nomo Robo.
Yes.
That's, it basically does like a dual dial out. And then if it's on the list, like this blacklist, it'll stop it, drop the call. So I don't know if other people are interested in that. So.
We've heard of Nomo Robo, but what we're trying to do here is very much beyond blacklisting and actually identifying who's behind it because of the problems I've mentioned about spoofing phone numbers and so on and so forth. Thank you.
Thanks.
One more question over there.
Yeah, thank you. So I recently saw different behavior. I often got calls from all over the US, but now it looks like I'm getting calls from my specific area code.
Oh, yes.
Is that something you've seen as well? I mean,
yes.
Probably people are more likely to answer if it's their own area
Absolutely.
code, right?
So we've seen that for specific scammers, not everyone. Specific scammers will systematically spoof their numbers to make it look like your area code. So we see, if you plot a graph, you see just little islands of each area code for source node numbers, robodialing only a given area code. But as I mentioned, there's a wide variety of scammers. You have some very dumb ones. Last year, federal agencies and AT&T stopped robodialers who were basically overloading a town in Virginia with calls. So many calls that nobody could use their phone, and so they had to do something immediately. So this answers your question. Sometimes they're just trying to reach whoever they can, and sometimes they're trying to be more crafty. But yes, we have seen this behavior.
Okay, thanks.
Sure.
One more question. I'm originally from Europe, and robocalls I didn't know about. It seems to be a US problem. Do you know why that is?
So it's funny you mention it, because we've been asking ourselves that question. There are some in Europe, but clearly a lot less. I think it's a problem of language, but English is easy for basically everyone in the world knows English, and it's easy to reach. Whereas we've actually seen robocalls in Spanish, and they cluster super well. The transcription makes no sense whatsoever, but they cluster really well. It's trying to transcribe Spanish words into English, just because clearly they are targeting some immigrant population in the US as well.
Okay, thanks.
Sure.
Yeah, I can add a little bit to that. I work for Sprint, and part of the issue in other countries is access, that they don't have as cheap and easy access to the network. And the other thing is some countries have stricter rules. Like in Germany, there is no telemarketing calls at all. They have like a very strict set of rules. So some of these countries do have a problem with this, and it's not as extensive, and they don't have the complaint mechanism like the FTC and the FCC has. So there is concern on an international basis, but it's not as public as it is in the US.
Thank you for the clarification. One person over there.
So you had mentioned that you're trying to go beyond blocking to identify the actors responsible. Are you taking these 38 key infrastructures and trying to tie them to the individual humans behind it and their nefarious networks?
So that's ongoing research. I don't have a conclusive result to show now. That's something that's very much of interest for the industry. Right now, the way federal agencies mostly do that, when they're trying to trace back a particular call, they have to subpoena the corresponding carrier and then go back from carrier to carrier. So this, for instance, is an advancement. It can tell you which group of calls likely came from the exact same original device and probably took the same channels, various channels to get to their destination in the US. So it's a first, it significantly decreases the complexity of backtracing. But that's, the holy grail, to be able to say, oh, based on your audio signal, I know where you are and where you live and what your name is. But we don't have that yet.
Okay, thanks.
Sure. Over there.
Do you know how many unique phone numbers place those 51% of the calls?
No, but I can find it if you really want to know. Okay. It's clearly less than 34,000 sources. I can find the number of phone numbers.
Thank you.
Sure. Any other questions?
So one thing I noticed with the 1-800 number is I get a lot of weird calls that seem to be contrived to draw the call out as long as possible. Did you have any 1-800 numbers in your set? I noticed lots of weird traffic on my 800
So
number.
we do have some of them. They're not the majority. We also have some states that have a very small population and yet place a lot of calls. And it might just be that they bought a block of phone numbers. If you actually look up in a given cluster the different source phone numbers and try to find, you can go in specific databases, find the carrier or maybe the attribution. It's really strange because some of these databases are outdated. And so you will find that one phone number belongs to this particular carrier, that's a traditional carrier, another will be a voice over IP carrier. Sometimes you have names that make no sense, like local services or internet services. So there's not much there. But we do see toll-free numbers for traffic bumping.
Thanks.
Sure. Any other questions? Well, thank you everyone for coming to the last session of the day.